Okay, on this example, it says you want to obtain a sample to estimate a population mean. Based on previous evidence, you believe the population standard deviation is approximately sigma equals 47.2. You would like to be 98% confident that your estimate is within one of the true population mean. How large of a sample size is required? So let me give a context to this to make it make sense. So what if you're trying to estimate how many months a new set of tires is going to last? Say a tire manufacturer comes out with a new kind of tire, new Michelin tire, a new brand of Michelin tire, and they want to test it. They want to test it and figure out how long it'll last on the road on average. That's a mean, right? That's an average. Will it last, will it last, 60 months, 72 months? Those are the warranties that come with tires. How long will it last? Well, you got to try out a bunch of, because not all tires are exactly the same. It's going to depend on the road conditions, the heat, the cooling, all that kind of stuff. So how many tires do you have to try out? That's the question. How large of a sample size is required? How many tires do you have to try? You want to be says you would like to be 98% confident. You want to be pretty sure. We could never be 100% sure, but that you're estimating ahead of time what the average lifespan of the tires is going to be within one of the true population mean. In other words, we always know the truth later, right? 10 years from now, after thousands of people have bought those tires and tried them out in their car, and we'll know how long they last on average. The truth will come out. On average, they last, 67 months or whatever, we'll know. Well, we want to know ahead of time because they have to set warranties and they want to know how good their product is and how much to charge and all that kind of stuff. Or if they should change the formula for the tires, they want to know ahead of time. You'd like to be 98% confident that you can estimate within one. You want to be this is a high demand. You want to be within one of the true mean, the true average. Now, whatever the true average is going to be known to be in the future, 10 years from now, when we know what the true average is after thousands of people use the tires, we want to be within one. We estimated it would be, 67 weeks. It was actually 68 or 66. We were within one. That's a high requirement. And you want to be 98% confident right now that you're within one. If that's the case, how large of a sample is required? How many tires do you need to try out to include in your sample? Try this tire. Okay, it lasted 65 months. Okay, let's try this other one. It lasted 71. Okay, this other one, then find the average for all those. And you want to be within one of the real thing that's going to be known years from now. You want to be 98% confident that you're within one. If that's the case, how many tires do you need to try out? How large of a sample? How big of a study on tires do you need to make? It's going to have to be huge. I'm guessing 10, 20, 30,000, maybe 100,000. I don't know. It's kind of ridiculous to say you want to be within one. But anyway, where are we going to go? Let's go to the notes. Here we are, Unit 3, Chapter Notes. Come on down. Sample size. We're on number 3, sample size. Is it a percentage question or a mean average question? Well, it's a mean average. You see the back here? It said mean. Sometimes it says average, right? Mean up here. It's not a percentage. You might say, well, yeah, but there's a percentage right here. Yeah, well, there's always a percentage for the confidence level. That doesn't mean percentage. I mean, that's a percentage confidence. That's not what we're trying to estimate a mean, an average, like how long will the tires last on average. So we're coming down here to the mean average. Go to the online calculator, sample size for a mean. So go to the online calculator. Here we are. Sample size for proportion, number 13, no, up on 11. Sample size for a mean, that's the one, number 11. Sample size for mean. So it opens up and there's the little sigma. That's the Greek S, stands for standard deviation. Okay, 47.2. Just plug that in, 47.2. That's the standard deviation. Okay, E, what is E? E stands for airs. It says up here, airbound. So like how close did you want to be to the real thing? You want to be within one. Within one. That we want to be. So within is always the air. Here, you can see that right here in the notes. It says E is air within amount. So we want to estimate ahead of time within 1 month what the average number of months is these tires are going to last. By the way, notice that that's not 1%, is it? It's just straight one. See it right here? It's one. It's not 1%. It's not like some of the other questions. Let me show you one of the other ones. This is one of the other questions that says within 2%. So then that would become a decimal, 0.02, because that's a percentage. No, no, ours is not a percentage. It's just a straight number within one. It's not 1%. Okay, so what? Well, that means I'm just going to put it in as one. I'm not going to change it to a decimal. The E is just one. I'm not going to put in 0.01. That'd be wrong. Just one. Why? Because it wasn't a percentage. Only percentages need to be changed to decimals. That one is not a percentage. It's just a straight one. So don't change it to a decimal. Okay. And coming on back, wait, where are we at? And then 98% confidence. Now that is a percentage. And percentages, we do change to decimals, move it back two places. That's going to be 0.98, right? So come on back here. That's going to be my confidence level, 0.98. And then calculate it. It's going to be huge. Yeah, 12,050. So you're going to have to you're going to have to try out 12,057 tires. Maybe we shouldn't try to be so close. You know what I mean? Within one. Okay, let's see if that's right. 12,057 tires. Yep, that's the answer. 12,057. Let's play with this for just a minute. What if, okay, we only want to be within 5 months. I mean, that's close enough, right? Let's get rid of this. Let's Let's calculate it. Oh yeah, there we go. If you only want to be within 5 months of what the real thing is, you only have to try out 483 tires. See how you don't need to do so many if you don't want to be so darn accurate? Or how about 6 months? That's half a year. Okay, we say, I just want to be within 6 months. All right, you only needs 335 tires. Just try out 335 and you'll be able to estimate. And what if we don't need 98? What don't we, so how about we say we just need 95% confidence? How about that? Now we only need 238 tires. That's more reasonable. We say, okay. How about just 90%? And we want to be, let's stick with it with the 6 months. There we go. That's getting more reasonable. Now we can just try out 168. So if you try out 168 tires, and you'll be 90% sure that you're estimating the real average within 6 months. Anyway, so that's how you can play with this calculator. And the company might say, okay, yeah, we can do 100, we can try out 168 tires. That's more reasonable. We'll be 90% sure what the real average life of the tires is within 6 months of the real thing, So that'll be pretty close. So there we go.